Hi, this is Ben Finio with Let's Go Boys and Girls, and this training video will walk you through how to make a brushbot with your students. And one caveat is that I'm doing this in one continuous take, so if anything goes wrong, hopefully you will see some of the common mistakes that students can make as well, or even anybody who's done this before, and I'll walk you through in real time how to deal with those mistakes and fix them. So, in front of me here you can see the main components you'll need to build the robot. You need a scrub brush of some sort. For the basic version, although you're certainly not limited to this, if you just want to give the students a pile of arts and crafts materials, popsicle sticks, toothbrushes, pipe cleaners, cardboard, all that kind of thing, they can certainly use something else to make the body of the robot. I think that's one of the parts they have the most fun experimenting with. But the elements that you really need over here are a battery pack, AA or AAA batteries, depending on the size of your battery pack, a toy motor, and a cork. The basic principle here is that I'm going to put the cork onto the shaft of this motor off-center so that when the shaft spins, that causes the motor to vibrate. This is the same principle that causes cell phones to vibrate or video game controllers, even electric toothbrushes. So those are things you can ask the students about since most of them are familiar with cell phones and game controllers. And then when you hook that up to the battery pack, this battery pack has a little on-off switch that lets you control the robot. So the first thing you'll need to have them do is just take the battery pack and the batteries and paying attention to the polarity, meaning the plus and minus signs. You know that batteries usually have a plus sign printed on one side. They do not have a minus sign printed on them. And then in the battery pack, you see that facing in opposite directions, we need to put the batteries in facing the right way. So this really isn't too complicated, not much different than just putting batteries in a TV remote or something, but you do want to be careful to make sure that they don't get the directions mixed up. And then most of these battery packs have a cover that you can pop on. Sometimes they also have a little screw you can tighten, but normally the cover will do it. And you'll hear a nice loud snap once that actually snaps into place. So the next thing to do is prepare the motor. And I, of course, found this out the hard way. In the first take of this video, I had the cork fly off into the camera. It's really not sufficient to just press the cork directly onto the shaft of the motor. You're going to need glue to hold it on there. So to speed things up here, I'm going to use a hot glue gun. You could probably get away with regular craft glue, but if you're crunched for time in a classroom and you don't want to wait for glue to dry, the hot glue will solidify much faster. So I have already pressed this cork onto the motor shaft to make a hole. So what I'm going to do now is fill that hole with glue from my hot glue gun, and then come and quickly, before that glue cools, press the motor shaft into the hole. Be careful not to let too much glue actually drip down into the motor because that will clog it and prevent it from spinning. So I'm going to give that a second to cool, but make sure that the cork can still spin freely and I haven't accidentally glued the cork onto the shaft of the motor. Glued the shaft of the motor onto the body of the motor. You want to make sure that the cork can still rotate. So I should also mention that depending on where you buy these motors, some of them will come with wires attached and some of them will not. So I don't know how well you'll be able to see this in the video, but this motor just came with two little tabs on the bottom, and I used a soldering iron to solder these wires on. If you don't have a soldering iron, you could just twist the wires on and then use electrical tape to hold them there, but that's much more likely to fall apart. So definitely recommend either buying motors with wires already attached or soldering them on if you have a soldering iron available. So the next step is to make a connection between the motor and the battery pack, and you can do this just by twisting the wires together. So here I'm going to twist red to red across the two wires, come in and twist them together, and then do the same thing with the black wires. Now, in this instance, it doesn't actually matter if they get red and black crisscrossed because the motor will spin in either direction, but it's probably a good idea just to instill the good habit of making sure that they're color coding and that positive and negative. In electronics, red usually stands for positive and black usually stands for negative, making sure those two things match. So, tell them to be careful to match red to red, even though it doesn't actually matter in this case. And now if I come along and flick the on switch on the battery pack, see that motor actually gets spinning pretty well there. So There are a couple more things you can do to strengthen up these connections. If you do have a soldering iron, it's easy just to solder the wires together to make sure they're really not going to fall apart. If you don't have a soldering iron, you can just use electrical tape to wrap around to help the connection mechanically and to make sure you don't get a short circuit if those two little exposed nubs of wire bump together. So I'm just going to come in here with electrical tape and wrap a couple times around each connection to help make sure that those don't fall apart later. So I'm going to cut one more piece of tape off camera here. Come in and wrap that up. So now that you've made that, you want to double check and make sure that your motor spins when you turn the battery pack on. Now you need to connect these to the body of the robot somehow. Now how you do this might vary depending on the materials you have available and what the students are doing. For example, sometimes you can get away with using duct tape or double-sided foam tape instead of glue. I found that with smooth, flat, relatively non-porous surfaces like the top of this brush, that a hot glue gun works much better than tape. Again, in my disastrous first attempt at this video, I tried to just pop these on with masking tape, with the double-sided tape, and then when I turned it on, both of these immediately flew off. So I highly recommend, in this case, using a hot glue gun, especially for the motor, which is going to be vibrating a lot more. And one important consideration is to make sure that the cork has clearance to spin. So if I just put the motor directly in the middle on top here, the cork can only spin 90 degrees in either direction, but it needs to be able to rotate continuously. So I'm going to come in and put some hot glue towards the back of the brush, and then plop the motor down where I am pretty confident that the cork is going to be able to rotate continuously. Give that a second to cool. And then do the same thing with the battery pack. I'm just going to put a little dab of glue down, plop the battery pack down, and there I go. Now, maybe give it a shake to make sure those really aren't going to come off once the glue is dried. And then, of course, you probably want to let the kids have fun and decorate, so I have googly eyes here to give the guy a little bit more personality. If I come in and switch the motor on, you can see it starts buzzing across the table. Now, turn this off so you can hear me talking. One thing you probably noticed immediately is that the robot isn't really going in a straight line, and that's because the bristles on this guy are mostly pointing straight down. One of the secrets to getting these to go faster or in more of a straight line instead of turning left and right or just spinning in place is to have slanted bristles. So when I just ran over to Target and looked at the scrub brushes in their section, most of the ones that I saw were shaped like this. This is actually something that's easier to find with toothbrushes. There are a lot more toothbrushes with slanted bristles. Let me see if I can actually grab some off my shelf here. So, for example, these guys are some fancier toothbrushes with all these bristles that are facing backwards. So if you make, say, a version of the robot that instead of using one large scrub brush like this has 4 tiny toothbrushes for feet, that would probably go a lot faster. So that's one of the fun things that you can let the students experiment with, is give them all these different materials. The base part is always just going to be the motor and the battery pack, but the challenge is to figure out what the shape of the body of the robot's going to be, what that's made out of, and then especially what are the feet, what comes in contact with the floor, and how can that help it make the robot go faster and go straight. You can also change the orientation and position of the motor and the battery pack. These are pretty heavy, so they're going to move the center of mass of the robot around. You can try reorienting the motor such that it's spinning in different directions and see how that affects things. So there are a bunch of different variables that kids can play with, and you can set up a competition like having them race the robots or have the robots sumo wrestle, where you put 2 of them head to head and have them push into each other. So hopefully that gives you a basic idea of the activity. There are a couple other quick troubleshooting things I'll go over. If you have kids coming up to you and saying, mine's not working, my motor's not spinning, the most common things you'll see are either they weren't quite paying attention to where they put the motor, and the cork is actually getting stuck. So you can imagine if I had moved this motor back a couple millimeters, maybe the corner of the cork would be nicking the body, and if I turn it on, it might start spinning and then stop, and they might not know why. So make sure that there's no obstruction on the cork, make sure that they didn't accidentally glue the motor shaft shut. The next most common thing I'd say is that these connections come undone. So after this has been wrapped in electrical tape, these two wires inside that might not be touching each other, and you wouldn't be able to tell. So undo that connection and double check and make sure that the wires are touching each other. The third and final thing that's less likely but can still sometimes happen, and I'm going to yank these apart just to show, is to actually test the batteries if you have a multimeter handy. If you haven't used a multimeter before, that's beyond the scope of what I'm going to cover in this video. But I have a multimeter here that I'm going to set to measure DC voltage, and then on my probes I have alligator clip adapters. I highly recommend you can pick these up at Radio Shack. They're great for testing things because you can clip onto what you want to test and then you have your hands free to do other things. So I'm going to clip on to the battery pack, and then when I turn the battery pack on, I get around 3 volts, which is what you should get from 2 fresh AA or AAA batteries. They provide 1.5 volts each. So if you do that and you turn the battery pack on and you get nothing, or a lower voltage, if you're getting a lower voltage that's not 0, that probably means the batteries are just actually dead and need to be replaced. If you're getting 0, that probably means they either put the batteries in wrong or the battery pack itself could be defective. Sometimes these are cheap and poorly assembled, so there are a couple little internal metal springs that can come loose, and the batteries can be perfectly fine, but there might not actually be a good electrical connection to the wires. So we have seen that happen a couple times where I look at a kid's robot and everything checks out fine, and these connections look good, but I open the battery pack up and it actually turns out that something jiggled loose in there, so it wasn't their fault, and the kids can get kind of confused. The other thing you can do, if everything else checks out and you have no idea why the motor isn't spinning, is to make sure that the motor hasn't burned out. So if your multimeter has a continuity test, that means you set it to a mode where it just beeps if there's a connection. So if you take the probes and just bump them together, you get a nice obnoxiously loud beeping sound. And since the motor is just essentially a really big coil of copper wire, if I clip on to both of the motor leads, I should get that beeping noise, because that means there's just a complete conductive circuit all the way through the motor to both of these leads. So if you do that and you don't get a continuity beep, or if your multimeter doesn't have continuity but you can measure resistance, you should be able to measure very low resistance. If you're getting a high resistance instead, that means something could have mechanically broken inside the motor, or it could have overheated and one of the wires could burn out. So there are, of course, I can't make an exhaustive list here of things that could possibly go wrong, but having run the workshop myself, those were the most common ones that popped up. So hopefully your kids will have fun with it. Remember, don't just pigeonhole them into what I've showed you in this video, but really let them go crazy with the design of the robot, the body, and where they want to put all these different components, and that should let them get the most out of it. Thanks.